Imagine you build a machine, step inside, and travel decades into the past to do the unthinkable. You pull a trigger and kill your own grandfather before your parent is even conceived. What happens to reality? It sounds like pure science fiction, but time travel is an established mathematical reality. In fact, traveling into the future happens constantly. Because of a phenomenon called time dilation, astronauts orbiting Earth aboard the International Space Station are technically living about 13 milliseconds in the future compared to the rest of us. But coasting forward is just a matter of speed. Returning to the past requires breaking the very structure of reality itself. To understand how, we have to look at Albert Einstein's theory of general relativity, which proved that space and time are part of a single flexible fabric that can warp and bend under extreme gravity. This diagram illustrates what physicists call a closed timelike curve. Under the right conditions, specific cosmic structures like rotating black holes or wormholes could theoretically warp space-time so severely that a timeline folds back onto its own past. Which brings us back to your grandfather. If you follow this curve to prevent your own birth, you would never exist to build the machine in the first place, creating an impossible logical contradiction. To determine what would actually happen if you stepped into one of these loops, we have to run the scenario through the three leading theories of modern physics. Let's initiate the first run. You activate the time machine to change the past, but before you can even step inside, the equipment violently breaks down. This outcome relies on Stephen Hawking's chronology protection conjecture. He theorized that the laws of physics possess a built-in defense mechanism against macroscopic time travel. The moment a wormhole tries to connect the past and present, vacuum fluctuations and quantum feedback loops would instantly build up and destroy the portal. In this timeline, the universe protects its own history by keeping the doorway to the past mathematically sealed. Now, run 2. You successfully navigate the wormhole, travel to the past, and aim your weapon. But a highly improbable coincidence occurs. The gun jams, or you inexplicably miss. This aligns with the Novikov's self-consistency principle, which dictates that the probability of executing an action that alters a past event is exactly 0. This model relies on the block universe concept. As you can see in this 3D cube, the past, present, and future are not flowing. They exist simultaneously as a static, unchangeable structure. Your attempt to change history creates a causal loop. Traveling back in time doesn't alter the past. Your arrival is the exact mechanism that caused the past event to happen in the first place. In this timeline, time travel is perfectly possible, but human free will is a complete illusion, strictly constrained by deterministic physics. Run 3. You pull the trigger. The paradox occurs. You successfully change history. The quantum many-worlds interpretation resolves this by splitting reality itself. As this diagram shows, the exact moment you alter a past event, the universe exfoliates. It spawns a completely new, parallel timeline branch where your changes take effect. The catch is that your original timeline still exists completely unaltered. By making the change, you permanently exile yourself from your home reality. In this timeline, you didn't actually change your history. You simply abandoned your original universe to birth a new one. If the many worlds theory allows us to rewrite history without destroying the universe, it raises a difficult question. Do we have a moral imperative to build time machines and stop horrific historical atrocities? When confronted with the sheer human cost of history's worst crimes, the temptation to intervene and erase that suffering is intense. But MIT quantum mechanic Seth Lloyd points out a severe limitation in this branching model. A time traveler isn't actually saving their own victims. They are just spawning an alternate reality, while the original suffering remains completely intact. The moral imperative to change the past fails. Time travel cannot offer salvation to those who have already suffered in our native timeline. Which brings us to the ultimate paradox. If time travel is theoretically possible, why is there absolutely no evidence of future humans visiting our present? Economists and physicists suggest a few reasons. Either future entities recognize the catastrophic risk of uncaused correlations unraveling their reality, or our current era simply doesn't contain enough lost knowledge to justify the astronomical energy costs of operating a closed timelike curve. Whether we are protected by quantum vacuum fluctuations, trapped in deterministic loops, or scattered across infinite multiverses, The laws of physics ensure our history remains untouchable. Because the deadbolt of physics locks us out of the past, the future is the only direction we are truly free to rewrite.